Okay, good afternoon, ladies and gentlemen. Welcome to the live stream. Right here, we will be doing harder integration by parts quiz, and we have a total of 8 questions. You guys can go download the file, and the file is in the description, all right? So let's just get right into it. Hopefully, you guys will have a chance to look over the questions, and I have my little laptop right here. So if you guys have anything that you want to answer, yeah, just leave in the chat, right? And yeah, here we go. This right here, we have the integral of e to the inverse cosine x. Anybody want to give any thoughts on this? Again, welcome everybody. Hello, hello. And this right here is mainly for calculus 2, by the way, especially if you are taking Cal 2 and you want to just have a little challenge when you are doing integration by parts. And next week, we'll be doing trig integrals. All right, so here we go. I'm actually going to just take a u sub first, right? So let's go ahead and do that right here. I will let u equal to inverse cosine x. And then I will take the original on both sides. So this is the same as saying x is equal to cosine of u. From here, we can just differentiate both sides. We can see that dx is just equal to negative sine u du. And you guys know it. We'll take this integral to the u world. And you will see this is going to be really, really nice. This right here is equal to the integral, and we have e. And then this right here is just going to be our u. And then dx is equal to all that, which is we have the negative sine u du, like this, right? So that's really good. Now, I'm just going to clean things up a little bit. And I'm actually just going to put the negative in the front. Here we have negative integral, and we have e to the u sine u du. As you can see, after the u substitution, even though originally the integration right here looks pretty scary, but once we are in the u world, this is actually one of the integrals that we have done in class, right? And this is actually a repeating situation, but I want to give a special shout out to Professor Michael Penn because he showed us a really nice method that you do not have to write this down as an equation and like add it to the other side and things like that. So if you don't know what I'm talking about, let me demonstrate. So let me just, again, thanks to Professor Penn. Right? And if you guys don't know who he is, you guys should definitely check out his channel. So Professor Michael Penn, right? So this is what I learned from him. First off, I'm actually going to look at this right here, and you see, we want to do integration by parts. You can differentiate e to the u, and you can integrate e to the u. Likewise, you can also differentiate and also integrate sine u. They're both pretty easy, right? In that situation, I'm actually going to have 2 copies of this. But originally, we have -1. So this is what we have to do. First, we're actually going to write this down twice. So we have the integral of e to the u sine u du. And then I'm going to add it with the integral of e to the u sine u du. So I have 2 copies, right? But I have only -1 right here. So what we have to do is just multiply the whole thing by -1/2. So are we okay so far? This plus that is 2 integrals and then multiplied by the -1/2. We still have the original. Now check this out. For this integral right here, I'm actually going to do the integration by parts right here. Of course, the DI method. And we just need 2 rows. For this one, I will actually differentiate e to the u and integrate sine u, and you will see this is just e to the u, and this right here is going to give us negative cosine u. But for this one, I will actually differentiate and integrate the other ones. So I will actually differentiate sine u right here and then integrate e to the u. Well, differentiating sine u, we get cosine u. Integrating e to the u, we still get e to the u. So that's really nice. Now, have a look. All the way in the front, we still have the -1/2, and then let me actually put this down right here. I need to make sure I have enough space for everything. For this integral, I will put down all this in red. Well, when we multiply the diagonal, we know that's the first part of the answer. So we get this times that, which is negative e to the u cosine u. And then don't forget that when we multiply by this row, this is still going to give us an integral, right? Negative times negative, we have the plus integral, and this is e to the u cosine u du. like that. Well, we are done for that, which is really good. Now we do the second one. For this one, again, this times this, that's going to give us the first part of the answer, and that's going to be plus. So plus e to the u. This is going to give us sine u right here. And then when we multiply by this row, as you can see, we have a negative, right? And then this is integral, and let's put down e to the u first. And then we have cosine u du. And do you guys see it? Inside here, this and that are the same but opposite sign. So of course we can just cancel them out, which is very, very nice. So if you notice that it doesn't really matter which part to be differentiated or which part to be integrated, give this kind of technique a try. So that way you don't have to write an integral equation and then add it to both sides. You don't have to do it like that. Really cool. Well, in the end, I'm just going to multiply the negative 1/2 inside, and then I will actually put a u back, and that's pretty much it. So let's see what we will end up with at the very end. Yeah. So finally, this is the answer. This times that we get positive 1/2, and then we have e to the u. And don't forget u is equal to that, which is cosine inverse, and then x right here. And then when we plug in this right here, actually let's look at cosine u, which is just equal to x. That's much better. And I'm going to put down x, so I think I will put down x in the front. Let me write this down right here. 1/2, right? And then this right here is x. And then this right here is just e to the cosine, and then inverse, and x. So that's the first part. And then for the next part, we multiply this and that, so we get negative, and then we have 1/2. And well, what is sine u though? We know x is equal to cosine u. So what is exactly sine u? Of course, what you can do is just plugging this right here into the u here, but that will be pretty intimidating. That's not that great. So let's do some work right here. If you look at this right here, cosine u is equal to x, which is the same as saying x over 1. Yes, I like to draw the special right triangle, so let's go ahead and draw the right triangle. So right here, you can see that this is going to give us, well, cosine is x right here, adjacent over hypotenuse, which is 1. And then the angle is the u. And to figure out hypotenuse, this right here is just equal to, you open the square root, and you do the hypotenuse square minus the other side square. Yeah, just like that. So as you can see, by looking at this triangle, sine u is just opposite over hypotenuse, which is just that, right? So I will put that down first. Then the square root of 1 minus x squared. And as a friendly reminder, 1 squared is equal to 1. I didn't forget to put down the 2. Anyway, yeah. Anyway, last part, we have e to the u, which is e to the cosine inverse of x. And we are all done. And you guys know the deal. Plus c somewhere. Just put it down. I like to write everything on the same line whenever possible. So, ladies and gentlemen, this right here is the first one. Yep. So, any questions on this? So just take a look right here. Yeah. And later on, for the people who cannot watch live stream, this right here will still be available for you guys. So, yeah. I picked these questions and I thought these are really interesting. And if you are taking Cal 2, then you should be able to follow along. But later on, we have like a couple that's like really, I don't want to use the word outrageous, but maybe it is outrageous for some of you guys. So this is the first question, and let's move to the second one. How are you guys doing? You guys can let me know. I don't know if I can erase the board while I read the messages. A lot of people are telling me to put on plus C. So yeah. Have I ever forgotten to put on the plus C? In fact, I forgot to put on plus C one time last semester when I was teaching Cal 2 on Zoom. And I think that's like the most recent one that I remember. I don't remember if I have forgotten to put on a plus C when I was a student. So I really don't know. It's not because I don't want to admit anything. It's that I don't remember. And you guys can let me know if you guys are taking Cal 2 or not. And you guys can also let me know where you are from. I might not be able to see your message right now, but later on I will rewatch the video and also try to enter the timestamps for you guys. All right, ladies and gentlemen, number 2. Here is the integral, and we have the inverse. And you think I'm just going to put on inverse tangent, right? No. Inverse tangent, you know this is the harder version of the quiz. So let's go ahead and put down square root of x inside. So just a little bit harder. Just a little bit harder. Yeah? So hopefully, you guys really have a chance to try all these questions on your own before you watch the live stream. So this is how we are going to do it. You might want to do a U-sub first, but I tried it. That's actually slightly longer. It's actually easier if we just go ahead and do integration by parts. Remember, for integration by parts, we are trying to integrate just one part of the integral and then differentiate the other part. But technically here, we just have one part right here, right? So we really have no choice. We actually just have to try to differentiate this instead. And let's see what will happen. Now that's pretty much a style. If you don't know how to integrate this, maybe try to differentiate that. But now you might be wondering, how about the other part? Yeah, we can just put down a 1. Yep. So even though you only see 1, but actually you can even though you only see one function right here, but you can always try to integrate 1, which is technically the dx right here. All right, let's do the easy part first. Integrating 1. Everybody happy. Okay, differentiating inverse tangent of square root of x. Well, we get 1 over 1 plus this thing inside here, and you square that. So we have square root of x and you square that. And of course, don't forget the chain rule. Multiply by the derivative of the inside. The derivative of square root of x is 1 over 2 square root of x, like that, right? And now let's just see what will happen after this. I cannot guarantee that this will work every single time, but it's just going to be a good try. All right, so ladies and gentlemen, we have the first part of the answer. This right here is equal to x times the inverse tangent of square root of x, which is pretty nice. Now, don't forget, when we multiply by this row, this is still going to be an integral. So let's see what will happen. Can we really integrate this? This is going to be a negative integral. Put this on the top, and then put down the 2 right here first, and then we have the square root of x, and then we have that, which is actually just 1 plus x, like that, yep. Well, you can actually simplify this whichever way that you would like. You can look at this as x to the first power divided by x to the 1/2 power. 1 minus 1/2, you get positive 1/2. So in fact, this is just going to be simplified into square root of x on the top. So that's pretty much all we have. And in fact, this is actually doable. Let's use the blue pen for the first time today. Let's do it on the side, just for this part. Here, let's see, what's the integral of? We have the square root of x over 1 plus x. And perhaps, should I put on the 2? I think let's just put on the 2 as well. Let's see what will really happen, right? So let me include the 2. All right, so right here, let's do a U substitution right here. And hope for the best, I will say. Take u to be square root of x. Take u to be square root of x. I shouldn't say it's pretty natural, but just give it a try, right? Well, right here, we need to get dx. It's actually a good idea to square both sides first, because you can isolate the x pretty easily, and then differentiate this. You get dx being equal to 2u du. So that's actually the straightforward method to get the dx in this case. Well, this right here gives us 1/2 integral. This guy is the u over 1 plus x is the same as u squared. Dx is equal to 2u du. Hey, it's actually really good that I brought the 2 on the bottom with us, because the 2 on the bottom can be cancelled out with this 2 right here, right? So that's pretty good. And then in fact, this becomes the integral, and then we have u, which is u squared over 1 plus u squared du. And now, how can we do this? U squared over 1 plus u squared. This is actually my favorite approach. I like to ask myself, wouldn't it be nice? Right? You ask your question by starting with the phrase, wouldn't it be nice? Look at this and you ask yourself, wouldn't it be nice? Well, what? Wouldn't it be nice if we actually have 1 plus u squared on the top instead? Yes, because in that case, the whole thing is just going to be 1, which is very nice. So let's go ahead and just put a 1 plus right here, but of course I cannot just do that. Otherwise I change the whole thing. It's actually not so bad because we can just minus 1 and pretty much pretend nothing happened. But you can see that this is so nice because this part, 1 plus u squared over 1 plus u squared is just 1. And then, if you like, you can close the integral, but let's put everything inside. We have then minus 1 over 1 plus u squared. And keep in mind, we are in the u world. Because when you integrate 1 in the u world, you will have to put down u. Yes, u. U. And then minus inverse tangent, that's the integral of that. And then here we have the u right here. So that's pretty much all. And then of course, in the end, we just have to plug in the square root for the u, square root of x. So finally, this is what we have. And you know what? I'm not going to put on the plus c right here. Why? Because this is just like an appetizer. This is the main dish. So ladies and gentlemen, right here, I'm going to write down x times the inverse tangent of square root of x minus, I'm actually going to distribute the minus right here, so check this out, minus times that, which is minus square root of x, right? So again, let me just emphasize we are distributing the negative right here, and then minus minus, we get a plus right here, and then we have the tangent, and this is the inverse, and then we have the square root of x. Man, again, I'm about to run out of space for the plus c, but of course, you have to always put on the plus c. So finally, this right here is the answer. So this right here is not so bad. It's like a combination of integration by part question and also maybe not so clear trick, no, not trick sub, I mean u sub question. By the way, u sub is fundamental, right? You can, it's almost like you cannot run away from u sub. So that's why I didn't really make a video on just the u sub quiz. So okay, so take a look, take a look, take a look. Did I get it right? Maybe you guys can double check with me. So let's see, I want to take a look at how many people are watching. Well, we have 439 people watching right now. Thank you guys all so much. So I'm looking at the chart right now. You guys can let me know where you are from, how you guys are doing. And all right, cool. So now I'm just going to erase this, yeah, and then we'll move to question number 3. So we have 8 questions, and we should be able to finish this within an hour. So that's the goal. It's really not like a quiz. It's actually pretty long because when you're doing a calculus 2 question, especially you are taking Cal 2 for the first time, one integration can take a pretty long time, right? So I shouldn't have called this a quiz, but anyway, too late. All right. All right, next one, number 3. This is not so bad. You can actually find this in like your standard calculus textbook, but it looks like it's pretty bad. It looks like it's impossible, but you'll see. All right, let me turn this to you guys for the first time today. Differentiating what part and integrating what part. Yes, we are doing integration by parts. So which part should we be differentiating and which part should we be integrating? So Billy, you said u sub 1 over x, and also that's the Nikhil, you say 1 over x for the u. Yes, that will work. And can I actually show you guys something else? I think this right here will be shorter and faster. And we'll actually do u substitution in our head. Yep. So let's just jump right into it for the integration by parts. Right here, pick one part to be differentiated, pick another part to be integrated, plus minus on the side just to get ready. It's always harder to do integration. If you look at this part right here, It's impossible. But just think about it. Which part can we actually integrate? If you look at sine of 1 over x, we have an inside function 1 over x. And remember, when we differentiate 1 over x, this gives us negative 1 over x to the second power. You see here we have x to a third power on the bottom. We have an extra x, right? Just push it to the part to be differentiated. So actually, let's look at integrating sine of 1 over x over x squared. And then we still have to have the 1 over x right here, right? So if you take a look right here, and if you multiply this and that, yes, we still end up with the original, right? And now let's try. So this is what I mean by you should always try to pick the part to be integrated. Whenever you can, just go ahead and give it a try and differentiate the other part and hope for the best. Let's do that first. To make us feel better, differentiating 1 over x is negative 1 over x squared. How do we know? I put it down right here for you guys already, right? Now, do a u substitution, let u equal to this. And you'll see that the x squared and x squared will cancel, but we end up with negative. Integrating sine, we get negative cosine, right? Negative cosine times negative 1 right here, it becomes positive. So we have positive, and then we have the input, which is just 1 over x. You can go ahead and just put this down and then differentiate this real quick in your head. Differentiating this, we get negative cosine. Well, differentiating this, we get negative sine. And then multiply by this, and you end up with that, right? So that's pretty good. Now you guys know the deal. Multiply this and that. That's the first part of the answer. And for let's still write this down. I like to put it down in this kind of order. So I'm going to just write it as 1 over x times cosine of 1 over x. Right, that's the first part of the answer. Then you multiply by this row, and this is going to be negative negative, which is going to be plus. So I will add on plus integral, and then we just have the 1 over x squared times cosine of 1 over x. Like that, right? Which is pretty good. And how do we do this? Yes, we do u sub again. Let u equal to 1 over x, right? So we're pretty much done. So I will write down the answer for you guys. All right, so here we have 1 over x. Cosine of 1 over x. Integrating cosine, we get positive sine. And then the input stays the same. All right, plus or minus right here. You guys do it. Plus or minus? Minus. Why minus? Because when you're differentiating sine, you get cosine, and the input stays the same. But use the chain rule, multiply by the derivative of this, which is negative 1 over x squared. Negative times negative will give you the plus, right? So it's negative. So, ladies and gentlemen, this right here is it, plus c. So, this is number 3, right? So, that's it. Okay, so that's number 3, and to do number 4, I really just want to erase this because I want to have enough space for every question. I cannot wait to go back to the classroom because I want to use the big board all over again, you know. But hopefully, this is not so bad, right? Hopefully you guys are okay with it. All right, number 4. We have the following. So here we have the integral, and then we have x times inverse sine x divided by square root of 1 minus x squared dx. Wow. You know it will be integration by parts somewhere because that's the topic today. But which part shall we pick to be integrated and which part shall we pick to be differentiated? Let me try this first, yeah? So if I'm doing this for the very first time, or I should say if you guys are doing this for the very first time as well, try this. We have three parts, three functions to choose from, right? Well, actually four because you have the one. So let's see. Do I want to just integrate x? Well, if I do that, then I have no choice but to differentiate inverse sine x over that. And this is going to be pretty horrible, right? When you differentiate this, you have to use the quotient rule. Yes, you have a really good time right here, but no. Sometimes you have to work hard for this. So this is the no right here. Right? So don't do it like this. All right. This is similar to what we did earlier. We have to just kind of pick the part that we can actually integrate. So now let's see, what if we do inverse sine x over square root of 1 minus x squared? Can we integrate this? The answer to that is actually yes, because the derivative of inverse sine is precisely 1 over square root of 1 minus x squared. So this is actually doable. Well, in that case, we will just have to put down the x right here for the differentiation. And let me give this a try and see how it looks. Differentiating x, we get 1. Integrating this, pick u to be inverse sine, and then it's just going to be integrating u in the u world. So you actually just get 1/2 u squared, which is just going to be inverse sine x raised to the second power. And if you guys have seen my video, thank you so much. When you have this kind of situation, please don't ever write this kind of notation. This is perhaps the worst notation ever. Don't ever do it like this. This means the inverse sine x and then raised to a second power. All right, so we achieved this, right? Not so bad. Okay, this times this, it's the first part of the answer, sure. But when we multiply this row, we will have to integrate 1/2 inverse sine x and then to the second power. I don't think that's enjoyable. Even though it's doable though, you just have to do integration by parts a few more times, but it's not enjoyable. So I'm actually going to stop right here. Right? This is actually not what we would like. Right? I leave this on the board just to show you that that's one of the things that we have tried. Now, let's use the blue pen and see what happens. Blue pen is here to rescue us. Well, that's a good idea, but we just have to maybe change it. The truth is, instead of putting down inverse sine x over square root right here, let's do x over that. That is still something that we can do. So let's integrate x over square root of 1 minus x squared. That's actually something that we can do. And then let's differentiate inverse sine x. All right? And yes, if you guys have seen the usual technique, the Liati, so L-I-A-T-E, like this method, which stands for you should differentiate logarithm function, inverse functions, algebraic functions, trig functions, and exponential functions. This right here, it actually kind of applies for this right here, because we do see the inverse sine x. This works for a pretty good amount of time, I would say, most of the time, but not all the time. You will see for later on. So that's that. But anyway, though, let's see. Differentiating inverse sine, we get 1 over square root of 1 minus x squared, which is really good. And now, ladies and gentlemen, when we integrate this, pick u to be the inside. The derivative of that is negative 2x. And the x will cancel out. And just work that out, you actually end up with negative square root of 1 minus x squared. Just go ahead and try this. When you differentiate this, you get negative 1 over square root of 1 minus x squared, and then multiply by negative 2x. Well, actually, you have a 2. The derivative square root is 1 over 2 square root, right? Negative, negative cancel, 2 and 2 cancel, so you get that back. That's all. Just do the gross sub on your own, and you end up with that. All right, this is so much better. Why? First off, we know this is the first part of the answer, so I'll write this down right here. let me put it down as negative square root of 1 minus x squared times inverse sine x. Right, so that's what we have. And then, of course, we are going to multiply by the second row, and this is still going to be an integral. Negative times negative becomes a plus, and then we have to integrate. Guess what? This and that cancel out very nicely. We just have to integrate 1. So multiply them, we have to integrate 1, and that's in the x world. So that's just pretty much x. Yeah, so finally, I'll just say this is negative square root of 1 minus x squared inverse sine x. And then we just have to add an x to it. And then guess what? We are done. So of course the plus c, just like that. So take a look. And let me see how many of you guys are watching. Still 439, that's pretty cool. And yeah. So the main discussion for today is that which part should we choose to be differentiated, and of course which part should we be choosing to be integrated, right? And again, the Liate, or however you want to pronounce it, L-I-A-T-E method, a lot of people find this to be helpful. So again, it stands for logarithm, inverse, algebraic, trig, and then exponential, right? When you have an integral right here, maybe you want to go in this order to pick the part to be differentiated, right? So that answers your question for that. All right, well, some people call this the latte method without the actual latte, of course. But anyway. Let me know if you guys are actually doing the questions as well. And then next week, we'll do the trig integrals, harder versions. And by harder versions, I meant to say that these are the questions I don't usually assign, or I don't usually put them on my calculus exams for my students. So my students, if you guys are watching, which is really good, and you don't have to worry about this kind of questions, especially the last couple ones. All right, number 5. This right here, I actually assigned this as a homework question. We are going to be integrating. We have natural log of x over 1 plus natural log of x, and then square, and then dx. So let me put a detail 2 right here, make it bigger. All right, you know the deal. We are going to be doing integration by parts. So if you would like, of course, put the d and also the I. And imagine that if this is just the integral that you see on the street and you have to integrate that, how would you approach this, right? Because on the street, you wouldn't know you should just use integration by parts every single time. Well, I would just tell you, look at this, you should always try to do U sub, right? You should always try to do U sub because I think that's the fundamental integration technique. So if you do U sub in this case, it looks like we'll just make the inside to be the u, which is going to be like this. So let's do some scratch work, and you see the du is just going to be 1 over x dx, right? But you will see that this is actually not going to be helpful at all. Yes, you can isolate the ln x, and it looks like we have ln x being u minus 1 on the top, and then over this right here is the u, and then we will have to square that. So it seems like it's not so bad, right? However, dx is equal to what though? Well, look at this. I will have to tell you dx is equal to x times du. And because u plus 1 is equal to ln x, well, we know that ln x is equal to u minus 1. So do e to the power on both sides. The x right here, it's the same as saying e to the u minus 1. So in fact, I will have to multiply by e to the u minus 1, and then of course the du. And because of this guy right here, and yeah, I don't think this is we are not making much progress. You can try to do integration by parts right here and continue, but let me show you another approach. So here's the deal. When you're looking at the integral, try to see if you can just come up with one part to be integrated and then differentiate the other one and hope for the best. I can only tell you guys hope for the best because there's no one method that will solve all the integrals in the world. So maybe Wolfgang Alpha, but no. Notice if I wanted to do U sub, I will produce the 1 over x. We didn't have the 1 over x right here, right? If we don't have it, why don't we produce it? So right here, I really want to have an x on the bottom because if that's the case, well, they will cancel each other out really nicely, right? But of course, I cannot just multiply the x on the bottom without multiplying the x on top. So let's go ahead and do that. All right? And now, I will actually just focus on integrating 1, right? 1 over x times 1 plus ln x, and then square. Why? Because this part right here, you can just do this u sub and it's going to work out very nicely. I don't want to have any functions on the top, right? Because what I can do is just differentiate the top. And again, hope for the best. So I will differentiate x ln x, all right? So that's pretty much the strategy or the scratch work that I will do on the side and try to figure it out. And that's also my thought process, right? So have a look right here. Well, let's do u sub in our head. Let u equal to 1 plus ln x, du is equal to 1 over x, so that will cancel. So we'll just have to integrate 1 over u squared, which is going to give us negative, right? Negative 1 over u, and u is equal to that, so I'll just put down 1 plus ln x. So that's the integration for that. So I should have said this is the integration for that. And then I will differentiate this. Well, use the product rule. Well, just put this on the side. I don't want to, yeah, let me just put it on the side. All right, product rule in action. First function times the derivative second plus the second function times the derivative first. So here we get 1 plus ln x. And do we see it? Yes, we do, right? Very, very nice, isn't it? So have a look right here. I'm just going to multiply this and that because that will give us the first part of the answer. Well, in that case, we get negative that, which is negative x ln x over 1 plus ln x. And then, of course, we are going to multiply by this row and putting inside alpha integration. Negative, negative is positive. Integral, guess what? This and that cancel each other out precisely. So just have to integrate 1, and this is in the x world. So of course, we just have to add x. So this right here becomes negative x ln x over 1 plus ln x, and then we just have to add x to it. I'm not done yet because I want to combine the fractions for you guys. Multiply this by 1 plus ln x, and then of course the top as well. And you will see on the bottom is just 1 plus ln x, and this is negative x ln x plus x ln x. So they cancel, and we just have an x on the top. Ladies and gentlemen, when you want to do the integration for that, the answer is just x over. Is this still connecting? It's back? Is it back? I'm sorry. Are we back? Are we back? Okay, perfect. Ooh, I don't know. Last night we actually have a problem with the internet as well. Not just my internet, it's actually the internet around the area. So unfortunately, I lost like 30 minutes of my Calculus 2 class. And yeah, okay, thankfully. So take a look right here real quick. Yep. And I cannot believe it's like 40 minutes already. So take a look, take a look, take a look. Yeah, so yes, things cancel off very nicely and yeah. And let me just tell you guys how I came up with this question. In fact, in my 100 derivative video, I was differentiating this function x over 1 plus ln x. And then I saw a very nice cancellation. Of course, when we differentiate this, we will end up with that for the answer. And I was just thinking, how can we integrate that from scratch? This is how. And you see, when we differentiate this, we will have to use the quotient rule, right? Remember, when we are doing the integration by parts, that's just a way to undo the product rule. And because product and quotient, they are really pretty much the same thing. So if you use the quotient rule to differentiate a function and end up with this, to undo the quotient rule, you still pretty much have to use the integration by parts. All right, that is number 5. 3 more questions to go. And you might be slightly comfortable with the special functions, but you just have to kind of get used to it if you want to study harder mathematics. So that's that. And let me put on the questions first. For the next question, this is what we have, right? This is what we have, number 6. So here's the keyword given. I'm going to tell you that when we integrate e to the x over x dx, this right here, it's actually, well, not elementary, but you can use special function for the answer for this. And this right here, we are just going to write it as ei of x. And the ei of x stands for exponential integral, and then x, of course, is just a notation for the function, right? So given that this right here is the answer, right? So again, you might feel, wow, that's something that we have never seen before. In fact, we have. I did a video on this like last year or 2 years ago. So if you would like to see more about it, just check out my other video for it. But anyway though, crazy ones, right? So, are we ready? Given this, we are going to integrate x e to the x. Yes, you are thinking, man, this is too easy. Don't worry. Multiply by ln x. All right, now let's talk. How can we approach this? Well, this time, because this is rather special, so I'll wait for you guys. Yes, differentiating one part and integrate the other part. Let me just ask you guys this first, yeah? Which part shall we pick to be differentiated and which part shall we pick to be integrated? And again, I'll put on the plus minus on the side to get ready for you guys. So let me know what you guys think. Which part shall we pick to be, let's do the integrating one. Yeah, which part shall we pick to be integrated? Anybody, anybody? Integrate x, e to the x, that is correct. So VULP1K, sorry, I just kind of lost the name, but I think that's your name, yeah. So we are going to integrate x, e to the x, and we will be differentiating ln x. And let's see if this is actually going to work out nicely or not. Do the easy one first. Differentiating natural log of x, we get 1 over x. Integrate x e to the x. Oh man. We still have to do integration by parts, right? So let's go ahead and do it real quick. D and then I plus minus. And actually one more because I will be differentiating x and then integrating e to the x. This is just going to give us e to the x every single time. And if we're differentiating x, we get 1. All right, I'm very sorry about the connection. I think we are back. Right now, I'm actually using my hotspot. So let's see. Where did we left off? Where did we leave? Where did you guys? Okay. Let me just explain this part one more time then. Yeah. Right? So I think these are okay. And then you see that this is negative. Integral of e to the x is just e to the x. Negative negative becomes positive like this. And the integral of e to the x over x is given. So we just have to write that down. So you have exponential integral of x like that. This time, I'm going to put down the plus c right here. What does c stand for? It stands for internet connection. Hopefully, I put down bigger C so that it will work until the end of the live stream. We just have 2 more questions to go, right? So hopefully, that's the deal. So take a look. I think this is pretty much it, right? And did you guys know that I hide Randy right here? And also have a Pikachu there. Yeah. So anyway, this right here is number 6. All right, just 2 more questions. And how are you guys doing? Are you guys enjoying this so far? I picked all these integrations, and hopefully you guys find them to be really interesting and also challenging. I'm just really, well, I don't want to use the word upset, but like, yeah, it's kind of upsetting about the internet connection for the day. I do have another class later on in like an hour or so, an hour and 30 minutes. So hopefully I'm able to use, hopefully the internet works because we have a test. All right, so 2 more questions. Number 7. Again, the keyword is that given. So we are given that the integral of sine x over x. Earlier, we have e to the x over x. That's called the exponential integral. Yes, this right here is called the sine integral. So we just write it as si and then write this down like that. So this is the name of the function, sine integral, and of course the input is just parentheses x. And yeah, you can put on plus c right here if you would like, but yeah. All right, so that's what we have. And here is the really intimidating one. So perhaps this is like the hardest one among all that we are doing today. We are going to be integrating 1 over arc sine, or the inverse sine, right, of x. But you think this is it? No. Put parentheses, square that. Right? This right here, if it's not on the bottom, if it's just inverse sine of x squared, you can just do integration by parts of it. It's not so bad. But when we have 1 over inverse sine of x squared, you actually have to utilize this right here. Yes, we still have to do integration by parts. So, oh man, how about look at you guys a little bit. You guys can tell me what we should do with this. And do not go to Wolfram Alpha and just type in the answer. Right? Don't do that. U sub, you can try that like u equal to this right here, right? And you will get like u square and yeah, stuff like that. So depending if you want to do u sub first or maybe integration by parts first, I think they are both okay. And then the physics cuber, yes, u sub, and then Andres and then u sub, and John differentiate inverse sine. Well, differentiating, you cannot just differentiate inverse sine because that's on the bottom, and even worse, it's inside of the parentheses square for that. So not so much. I'm not trying to erase the question. I'm just trying to make the 2 bigger, right? All right, now I'm a big fan of using integration by parts right away. So let's go ahead and do that. Go ahead, differentiate and integrate, and then plus or minus. Yeah. For this, for the people who will say to do u sub, yes, you can just say let u equal to inverse sine x, right? And you see, if you do that, you get du is equal to 1 over square root of 1 minus x squared dx. All right, so that's that. And I don't know why I just let you do this approach. I know you can just continue, but I think it's just because of what we did earlier. You see, in this case, it will be good if you have the square root of 1 minus x squared on the bottom. That will help us out really nicely, right? So right here, I'm actually going to multiply the top and bottom by square root of 1 minus x squared. So that's like what we did before, right? Just like a couple minutes ago. So let's go ahead and do that. I'm actually going to differentiate this guy, which is square root of 1 minus x squared, and then I will be integrating the rest, which is 1 over, let me put this down first, and then we have the inverse sine of x and then square, like so. Well, we differentiated this earlier already. This right here, we get negative x over square root of 1 minus x squared, right? Yes. This right here, what do we get? Do u sub, right? This is the part that you do u sub, but you can do u sub in your head. So you pretty much just integrate 1 over u squared again, and you get negative 1 over u, which is just inverse sine of x, like that. And it looks like I made the question a lot worse. I kind of did, but yeah. Anyway, still do the same thing. This times that, we get the following. So I'll put down the answer right here. We get negative, let me put this over that. So we have square root of 1 minus x squared over inverse sine x, right? So that's the first part of the answer. And again, oh my God, I have to integrate that part. Well, right here, negative, negative, negative is still negative, and then we have to integrate, and we'll just multiply everything together. So this right here becomes x over, and we have square root of 1 minus x squared, and then we have inverse sine x, like that, right? Wow. Let's see what are you guys talking about right now. That it's pretty crazy, right? Yeah. I think if you take this integral to the u world, might be better, but like I just like to do this kind of thing because we did that earlier today. And now check this out. I will still use the u right here because it works. So you will see that for this right here, we can actually just do u sub, and let's see. I'll just put this down over again because that's technical for this. Do u sub equal to inverse sine x, and you will see that x is equal to, actually, let's put it down like this. I have more space. U equal to that. X is equal to sine u, and then I want to get dx, or dx is equal to the derivative of that, which is cosine u du, right? Now, here's the best part. This right here is sine u, and we'll see we have the negative and then the integral. This is sine u on the top. So I'll put it down in, let's do this. Here we have the red, that's red. And then this is sine u, right? Sine u. And then here we have u, but we also have to face that. Now check this out. U is equal to sine u. And the truth is, this right here is just equal to cosine u. Let me just show you real quick. Let me put it down in red. Square root of 1 minus x, which is sine u. And then you square that. You see, inside here is cosine square. And you do the square root, just don't worry about the plus or minus or the absolute value. This is just going to be cosine x. So this right here is going to be cosine x. Right? So I'll put this down in red. No, cosine u, sorry. Cosine u. And then this right here is the u, so I'll put down another u right here. And the dx is equal to cosine u, which is very nice. You see, cosine u du. Ladies and gentlemen, you see that the cosine u and cosine u cancel, and we just have to integrate sine u over u, which is just si of u. So this right here becomes negative integral, oops, sorry. This right here becomes negative, and then we have si of u, and u is equal to that, which is the inverse sine x. Whew, crazy, right? And now I'm just going to put this down in the front. So here we have negative square root of 1 minus x squared over, we have the inverse sign on the bottom. So let me write it down better. I'm sorry about that. Man, all the disconnection kind of ruined my pace a little bit, but like, it's okay. So we have this minus that, and in the end, put on a plus c, and we are done. Yeah, I'm pretty sure there might be a fast way that you guys can come up with. Leave a comment down below and let me know. Yeah, let me know. All right, so this is number 7, one last one, yeah? But the last one is actually pretty cool. It's pretty useful because we'll actually come with a very nice formula for it. So, last one, yeah. I know I have some spots that I have not erased it yet, so just give me a second or so. You guys can let me know which one is your favorite so far, 1 through 7. And here's number 8, and I will show you this is the one. Again, the keyword is given. I will just tell you that given integral of a function, let's just write it as capital F of x. Right? Let's just write it as capital F of x. So if you're integrating a little f, you get big F, which is just like an antiderivative. Now, we are going to integrate, well, integrate the integral of inverse. Yeah, let's go ahead and do that. For this one, actually I've done it a couple times already, but to come with the formula right here, right? Let's just go ahead and use u sub. Here we go. I'm actually going to put it down right here. Let u equal to inverse f of x. Right? So once you have this right here, this is like one of the few cases that actually have to use the u sub first rather than just integration by parts first. But anyway, once we have this, we can take the original f on both sides. So this is equivalent to say x is equal to the original f of u, and then right here we can just differentiate both sides. So the derivative of x is just put down dx, but on the right hand side I will write down f prime of u. So this is the notation for the derivative of f, right? du. And now you know it. We'll take this integral to the u world. So here we have the integral. This right here is our u, and then the dx is that. So I'll write down f prime of u du. So that's what we have. Now, we have more things to work with, right? And in fact, this is the derivative. We can totally integrate that, and let's just differentiate that. So this is the place that we can do integration by parts. So I put on a d and an I right here. Plus, minus, to get ready, I'm going to be integrating f prime of u and then differentiating u. Well, differentiating u we get 1. Integrating that we get just f, right? Because integrating the derivative, they just cancel out, so we just get the original. So ladies and gentlemen, this right here is what? Well, we still do this times that as the first part of the answer. So we have u times f of u, and then multiply by this row and put it down in an integral. So we have minus integral 1 times f of u is just, of course, f of u, and we are in the u world. So we just have to integrate that. Well, let's see. Do we know about this? Yes, we do. That's just f of u, but with a capital F. So for this one right here, we're just going to write it down as minus capital F, and then right here we have the u. Because we're using u right here, so be sure you put down the u. Earlier it was x, so we have the x. So that's pretty much it. And of course, we have u f of u right here. So let me just write this down again. u times f of u. And let's focus on the u's because we are going to go back to the x world. I know a lot of you guys don't like me to do that, but yeah, I just did it again, I'm sorry. Anyway, u is equal to what? U is equal to that, so I'll write this down as inverse, right? Inverse f of x. And then we have f of u, which is actually just equal to x. So I will just put down an x right here, so multiply by x, right? And then we have minus f, and then the u is equal to that, so we have f of inverse f of x. Wow. We are pretty much done. Allow me to actually just write down everything in black and then rewrite the order. This right here is just x times inverse f of x, and then minus capital F of inverse of f of little x, like that. Yes, we're all done. Plus c, this is it. So this is a very nice formula when you want to integrate an inverse function, right? So that's pretty much it. Thank you guys so much for coming. And do you guys have any questions? I will just maybe take some questions from the chat right now. Which one's your favorite? Let me know. So I'm not blocking anything right now, right? So Einstein Gonzalez, yeah, it's scary. But please don't spam the chat. Yeah. And let's see. MCE, and you said 7. Which one is your favorite name? BG is 8. Number 3. And then so a lot of you guys were talking about 7. And I'm pretty happy that for number 7, the connection was okay, right? For not like. Which one is the one that had bad connection? Number 6, right? Oh, a lot of you guys like number 7, and some of you guys like number 8, and some of you guys like number 3. Right. Cool. Thank you guys so much for coming. And next Tuesday, same time at 1 p.m. Let me just write this down right here real quick. Let me just say. Next live stream is next Tuesday, which is when? When is next Tuesday? When is next Tuesday? I'll just say next Tuesday. (1 p.m. Pacific time, right? So I will again give you guys the questions beforehand, and if you guys are subscribed to my channel, you guys will see the little place that it pops out, and then you can just wait, right? And then you will just get notified for the next live stream. Thank you guys so much for coming, and as always, that's it.